In this problem, we are looking at the COUNTIF function to count percentage of defects in a sample, and then later on we will use the binomial distribution to do the same type of analysis. So you can pause the video and read the problem, part A, but for now let's go to to this page where the data is, and you can see that all the cells are occupied, and so we will use equals COUNTIF, and I will select the range, but I want to make sure that I hit function F4 or F4 key on your keyboard so that you can fix the cell reference, so that when I copy it down, it will still count these cells and does not go to the next row. And then the criteria is, of course, true, and there are 6 defective or true or defective phones in this sample, and if I copy that down, there are 244 that are not. So if I sum it up, I get my 250, and now I can compute my percentages, which is a fraction of 6 divided by the total, 250. Again, I'm gonna fix the cell reference so that I can copy that down and compute my percentage of false or not defective, which adds up to 100%. So if we go back to the problem, now it says if a technician takes a random sample of only 50 phones, and assuming that they follow a binomial distribution, what is the probability of, and 3 different questions are asked. So let's review briefly the binomial distribution. I have here the characteristics of a binomial experiment are these. We have a fixed number of trials. So in this problem, there are 50 phones. So n is equal to 50. Two possible outcomes for each trial, either success or failure, and in this case it's either defective or not defective. However, we're going to define a success event here to be a defective phone. Okay? Probability of success and failure are constant, so they don't change from one unit to another, and then the probability of success is denoted by the letter P, and therefore probability of failure is 1 minus P, because they must add up to 1. They're complements to each other. The number of successes range from 0 to n. So if we have n trials, then the number of successes could be either nothing in those 50 phones are defective, or all of them are defective, and then any number in between. And finally, each trial is independent of the other. So with that, we can define our X range, which is, actually we can have 0, 1, 2, 3, and I will copy that down to get about 50 or so. How many did I get? Maybe a couple more. Okay, so we have our X's to be 50, which is the number of trials, and then I'm gonna fix these so that they're centered, and probability of X therefore is, now I use the binomial distribution function, so binom dist, depending on which version of Excel you're using, you either may have to use only binom dist or binomial function. The number is right here is L5, Number of trials is over here, but I'm going to fix the cell reference. Probability is 0.024. Again, I'm going to fix the cell reference. And then I'm going to say false, meaning that I'm only looking at the exact probability of the binomial. So with that, I can copy that down. And these are exact values of each of these x values. So if the number of defects is exactly 3, then the probability would be, or that we would have a 0.09 probability of exactly having 3 defective units. So the problem, there are two different ways that you can solve these. You can, to find out what is the probability, so this one right here is the probability of exactly 2. Alright. This is the probability of exactly 2 right there. Now to find the probability that x is less than or equal to 4, which is this part right here, it says 4 phones or fewer will be defective. We can sum probability of 4 or fewer. A different way that you can get that is to say equals binom dist, and then again the number is 4, trials is 50, probability is 0.024, and I can say when it says do you want cumulative, you can say true. You do want cumulative probability, which means probability of everything up to 4. 0, 1, 2, 3, 4. And you can see that we get exactly the same number given rounding. Okay, and then another one is probability that x is greater than or equal to 6 or more, and this is equal to 1 minus binomial distribution of number is 6. Oh, it says 6 or more phones being defective. Actually, I want to solve it like this first. This equals summation of 6 or more. So that's from here all the way down. And that number is 0.00128. Now we can use it. We can use the binomial distribution, and it says 6 or more being defective. So if 6 or more, we want the 6 to be included in that range, then it's really probability of 5 or less that I want to subtract from 1. So I would have 1 minus binomial distribution of 5, number of 5, number of trials is 50, probability is 0.024, and I would say true. And again, we get exactly the same number, because in this case we're looking at probability of 0, 1, 2, 3, 4, and 5, and then we subtract that from 1, so that would be the probability of 6 or more. So 6 or more is over here. Okay, So that's that problem. I hope you found it helpful. Thank you.